Now coming to the long form of periodic table, you can see in front of you I have drawn a long form of periodic table. You can see here that is the period 1, 2, 3, 4, 5, 6, 7. There are 7 horizontal rows called periods, and there are 18 vertical columns. 18 I haven't shown here. This is first and second. This much is 3 to 12 and this much is 13 to 18. We can say that. Clear? So group 3 to 12 we know that it's transition elements, which we say it as a D block, and group 1 and 2 we call it as S block. Group 13 to 18 we call it as P block. You know it. And lanthanides and actinides comes under F block elements. The maximum capacity of F block is 14. So there are 14 elements. So 14 in each row. So 14 to the 28 elements are there. Alright, clear? And here that is 4 transition series are there. 3D, 4D, 5D and 6D. Containing each transition series containing 10 elements. How it is 10? 12 minus 3 plus 1. So 9 plus 1 is 10. So here 10, here 10, here 10, here 10. So maximum it is 40. Maximum it is 40. Here it is 7 and here it is 6. So it is 7 plus 6 is 13. We can say that. Clear? And here there are 13 to 18. How many? That is 6 groups. And 1, 2, 3, 4, 5. We can say that. Clear? Here you can see that is nothing but 1, 2, 3, 4, 5, 6. Clear? So in this way we are having 6 here and 1 more it is. So 6, 5 is 30 plus 1. Alright, how it is 6? 1, 2, 3, 4, 5, 6. And here 13 to 18, how many groups are there? 5. So 6 5 is 30 plus 1, that is 31. So you came to know 31 here, it is 7, 13 here, maximum 40, and here it is maximum 28. Got it? In this way. So this is just a general view of the periodic table I have given to you in front of you, which you have studied all these things. Lanthanides and actinides are placed outside the periodic table to prevent the periodic table from being unnecessarily lengthy. You also know the elements. Basically, this is known as alkali metals. This is known as noble gases or inert gases or aerogens, we can call it as. Why it is called aerogens? Because they are mainly found in the air. Helium, neon, argon, krypton, xenon, radon. They are found in the air. For that reason, they are called as aerogens. Group 17, before 17 is your 18, it is 17. 17 is known as halogens, absolutely. Group 16 is called as chalcogens, absolutely. Group 15 is called as nicogens. Group 15 is known as nicogens. Nicogens, we can say that. Group 16. Okay. So one theory suggests that in group 15, the first element is nitrogen, then after that it is phosphorus. So as nitrogen and phosphorus is there, so Pn, so it is nicogens. Some suggest that these, what you can say, it is called as nicogens because their hydrides are basically gaseous. We can say that. They are hydrides like ammonia, NH3, PH3 phosphine. After that you will be having ASH3, SBH3. They are basically gaseous. Alright, we can say that. Clear? And they are basic in nature, we can say. Clear? Except phosphine, we can say. Now, in this way, so different concepts is given, different views are given regarding this, we can say. So, this is about your group 15 element, we can say that. Clear? Achha, that is more about it I have said you in my previous AV I have told to you. Now, the elements here is nothing but it is hydrogen, then it is lithium, then sodium, then potassium, then rubidium, then cesium, then francium. We can say group 1. And group 18 already I have discussed with you. Helium, neon, argon, krypton, xenon, radon, and UUO. We can say that. The last one, which is not yet confirmed, we can say that. Clear? The first consists of 2 elements. See, the first period consists of 2 elements. Second period consists of 8 elements. This is short. First period is very short. Then it is short. The second one is, third one is also 8. It is also short. Then 4th and 5th is long, 18 elements each. 6th is 32, very long, and 7th is incomplete till today we say it as. Alright, so in this way we know it, all these things about the periodic table. The one which we do not know, that is what I am going to discuss with you. The one which you are not knowing. Now let us come, that is a group 1 elements. Now see here, I am going to discuss with you the secondary properties, little bit about it. Alright, so they are basically metals. They are coming in S block. Group 2 is also, they are coming under metals, they are S block. So they are solid basically. Definitely. Sodium, potassium, rubidium, cesium, calcium, magnesium, all these are nothing but solid. They are metals. Now group 13, it is nothing but metalloids. Group 13, we can say it is a metalloids. Listen carefully. Understood? Now group 14, 15, 16, 17, 18, they are all non-metals. And basically they are gaseous. Basically they are gaseous. Now in gaseous, if you say, then 14, 15, 16, 17, they are all diatomic or polyatomic gases. We can say that. But group 18, the inert gases are monoatomic in nature. We can say they are monoatomic gases. Helium, neon, argon, krypton, xenon, radon. I have told you about atomicity. Atomicity means number of atoms present in one molecule of a particular compound. We can say that. So in case of inert gases, number of atoms is 1. So it is monoatomic. In case of oxygen, number of atoms is 2. Because we write oxygen as O2. So it is diatomic. N2 diatomic. But ozone O3 it is polyatomic. Phosphorus P4 polyatomic. Sulfur S8 polyatomic. We can say that. Clear? So understood these things. So in this way we can say so metals we are having, that is your metals, group 1, group 2 metals. Then group 13 it is your non-metals, and that is metalloids of course, and this is non-metals. We can say group 14 to that is 18 onwards, we can say all are diatomic gases, mostly I say that, and diatomic or polyatomic, and group 18 is your monoatomic gases. They are non-metals, we can say that. Now if you see, that is group 3, what about group 3 to 12? Group 3 to 12 are all transition elements. They are basically metals, and they are hard metals. I have discussed with you all these things about it. They are very hard, they have got high melting and boiling point. I have discussed with you. Now next is, if you see, that is the ionic compounds. This one, they form ionic compounds. Group 1 and 2 elements, ionic compound, because they form ions. Got it? They readily lose electrons to form cations, and hence they combine with the group 17 or 16 or 15 elements, which are form anions to form an ionic compound. Got it? Achha. And these compounds are covalent. Which one? Group 1 and 2 they form ionic compounds, and group 13 to 18 they generally form covalent compounds. Alright? They generally form covalent compounds. Ionic compounds, basically you will find their solids, ionic compound, and covalent compounds they are generally liquids and gases. Generally, see, I am using the term, listen carefully, generally they are liquids and gases. Exceptions are always there. Alright, exceptions. But generally I am using that particular term. We can say that. Now you will find the nature of the oxides. If you see, they are metal, and their oxides are also metallic oxides. So hence you find their basic in nature. They are non-metals, group 13 to 18. So their oxides are also non-metallic. So they are acidic in nature. Now why do we say acidic? Sorry. Because their oxides dissolves in water to give you acids. Like sulfur dioxide gives sulfurous acid or sulfuric acid. Nitrogen dioxide gives nitrous acid or nitric acid. Phosphorus pentoxide gives phosphorus acid or phosphoric acid. Similarly, in group 1 and 2, that is sodium oxide, potassium oxide, calcium oxide, they dissolves in water to give bases. Some bases are also soluble in water. They are known as alkalis. Remember, the difference between bases and alkalis is that all alkalis are bases, but all bases are not alkalis. The reason is that all bases are not soluble in water. Whichever bases are soluble in water, they are known as alkalis, so to say. Alright, in this way, you got an idea that these compounds are basically group 1 and 2, they are what you can say, ionic compounds, and these compounds are covalent compounds. Group 13 to 18, they are covalent in nature, basically we can say that. Clear? Now, next is, that is, we will see, that is one more thing, that is your bridge elements or diagonal relationship. Now, there are certain elements of period 2 and 3. Alright, there are certain elements of period 2 and 3 when diagonally placed, like lithium, beryllium, boron. Alright, here it is, that is nothing but sodium, magnesium, that is aluminium, we can say silicon, one more I can say lithium, beryllium, sorry, B I have written, beryllium, boron, then it is carbon. So, lithium and magnesium diagonally, beryllium and aluminium diagonally, boron and silicon diagonally. Alright, see it. So, you can see the elements of period 2 and period 3, some of the elements, not all the elements, some of the elements of period 2 and 3, when diagonally placed, have properties similar to each other. So, these elements are called as bridge elements, and the relationship is known as diagonal relationship. Some of the properties are similar. Now, some means, for example, lithium oxide, even if it's an ionic compound, it is not soluble in water. Alright, it does not conduct electricity. It is not an electrolyte. Same thing about magnesium oxide. Same thing about magnesium oxide also. Got it? They are not soluble in water. They do not conduct electricity. Fine. Beryllium oxide and aluminum oxide, they are amphoteric in nature. Amphoteric means they react both with acids as well as with bases to form salt and water. Got it? Similarly, boron and silicon, they are hydrides. BH3 is known as what? Borane. Borane, we can say BH3 is borane. SiH3, it is known as what? Silane. Silane, S-I-L-A-N-E. Silane, and this one is B-O-R-A-N-E. Borane. So it forms hydrides, and the name is also similar. It ends in N, we can say that. Borane, silane, methane. Got it? In this way, we can say that. So in this way, you will find some of the properties. Just an example I have given you. In this way, some of the properties of the elements of period 2 and 3 when diagonally placed, got it, are similar. Some of the properties are similar, we can say. And hence, these elements are called as bridge elements, and they are said to have diagonal relations. Generally, what you find is the elements in a particular group, they have got similar properties. For that reason only they are placed in a particular group. Like lithium, sodium, they have got similar. Beryllium, magnesium should be similar. Boron, aluminum, carbon, silicon should be similar. Apart from that, it is similar. But apart from that, some of the properties, again and again I am saying, some of the properties are being similar when diagonally placed of elements of period 2 and 3, so to say. We can say that. Clear? Now, next is when you come down the group, in case of group 1 and group 2 elements, what you find is that I said they are metals. So metallic character increases. And in case of group 17, 16 and all these elements, you will find the non-metallic character decreases. Non-metallic character decreases. Listen carefully. Non-metallic character decreases. But when you come down the group, the metallic character increases. Now, why do we say? Because when you come down the group, number of shells increases. Number of shells. Got it? So, the electrons which is present in the outermost shell, it loses electrons readily, due to which it behaves as a stronger metal. Got it? Because metals are electropositive in nature. When you come down the group, number of shell, here 2 cell, 3 cell, 4 cell, 5 cell, 6 cells, because this number corresponds to the number of shells and that corresponds to the number of periods. We can say that. Clear? So in this, the number of shells is increasing. So it is easy for you to remove an electron from the outermost shell because you are going far away from that of the nucleus. You know that. The nuclear force is decreasing. As it is becoming easy for you, so it is readily forming an electropositive metal. Readily it forms. Got it? That is the element of period 6, the first group of the element of the period 6. Which one? That is nothing but lithium, sodium, potassium, rubidium, cesium. Cesium readily forms an electropositive metal compared to, that is your lithium. So it is more metallic in nature compared to that of lithium. So metallic character increases, non-metallic character decreases. Why decreases? If you see group 17 elements, fluorine, chlorine, bromine, iodine, we can say group 17 elements. So iodine is least, what you can say, non-metal. Alright, it is not so strong non-metal. Why? Because if you take the acids of it, HF, HCl, HBr, HI. So HI is a weak acid compared to HBr, compared to HCl, compared to HF. It's a weak acid, we can say that. HI is not strong acid, it's a weak acid. Clear? So what you find is that for that reason, non-metallic character decreases down the group because number of shells increases. So here it does not lose electrons, rather it gains electrons. Alright? Clear? Hence, what you find is that non-metallic character decreases down the group and metallic character increases down the group. We can say that. Similarly, basic character increases down the group and acidic character decreases because metals forms basic oxides. Basic character increases and acidic character decreases down the group. You should remember this particular thing. Alright? Nuclear charge remains the same. Yes, number of electrons here it is 1 in the outermost shell. Here the number of electrons is 2 in the outermost shell. We can say that. So the nuclear charge remains the same. The basic character increases in case of group 1 and 2. And basic character increases. And that is acidic character decreases because metallic character increases and non-metallic character decreases. So if you see the advantages of the long form of periodic table, then you will find long form of periodic table, that is, it is having a systematic study. Here we are having, because see, so many things I said you, these are nothing but the properties of the long form of the periodic table. The advantages is that if a particular element is not discovered, generally in group period 7 you will find the period 7, there is a elements of some of the elements of the D block and the P block are not yet been discovered. If at all it is the symbol, you know, I'll tell you that how you know the symbol. If at all you know the symbol, that does not mean that the element is being discovered. Or if at all the element is discovered, all the properties of the elements is not yet ascertained, but we can predict the properties of the elements. Why? Because it is from the particular group, we can predict that what should be the properties of that particular element. What should be the nature, whether it is metallic, non-metallic, acidic, basic, what is its valency, what should be the valency of that particular element. You know, the number of electrons present in the outermost shell determines the valency. Like here the valency is 1, here the valency is 2. In this way we determine the valency, the number of electrons. You have read it in the lower classes. So in this way, we can, from the modern periodic table, we can predict the properties of the elements which are not yet officially taken in the, what you can say, periodic table by the IUPAC system. It is not being included, but we know the properties of that particular element. We can predict the properties of that particular element, and when it will be discovered, when it will be officially included, then we will compare the properties and we will find it out that it is almost same, we can say that. The problem which was there in the Mendeleev's periodic table, the problem of isotopes, what it occur in different places, that has been solved in the modern periodic table, we can say that. So these are the advantages or the merits of the long form of the periodic table, isn't it? We are able to explain the periodicity of properties and the properties which gets repeated after certain regular interval of time. Here you can see the magic number which I said 2, 8, 18, 18, 32. 2, 8, 8, 18, 18, 32. So after these numbers, the properties of the elements gets repeated. The properties of the elements gets repeated, which is known as the periodicity of properties. That is one of the properties I can say, the atomic size, which what you can say is that across the period, if you see the atomic size is decreasing, and down the group you can see the atomic size is increasing. Why atomic size increases down the group? Because number of shells is increasing. Definitely the atom will become bigger in size because number of shells. Here it is 1 shell, 2 shell, 3rd shell. So if number of shells is going to increase, the atomic size is going to increase. The atomic size increases down the group. Across the period, why it happens? Because across the period the nuclear charge increases. Listen carefully here, nuclear charge. Because nuclear charge means the charge of the nucleus. What is the charge of the nucleus? Positive. Why? Because nucleus consists of protons and neutrons. Protons is positive charge. So proton, that is nucleus, is going to pull the electrons which is there in the shells towards itself. So as we are moving from left to right, number of protons is increasing as well as number of electrons is increasing because atomic number is increasing. Due to which the nuclear charge increases. That is called nuclear charge. And due to the increase in nuclear charge, it pulls the electrons towards itself. Due to which the atom becomes smaller and smaller. Are you following what I am saying? When you are moving from left to right across the period, left to right across the period, that is nuclear charge increases. That is nuclear charge means charge of the nucleus which is positive, it is increases. As well as number of electrons is also increasing. Now, if the protons is increasing, electrons also has to increase. Because atomic number means number of protons is equal to number of electrons. So that protons pulls the electrons towards itself. It is going to pull. When it is going to pull, the atomic size is going to what? Decrease. It is going to squeeze. It will become smaller. Alright. So hence when you move from left to right across the period, atomic size decreases. But down the group it increases. This is known as what? Periodicity of properties. This is called as the periodic properties, we can say that. So this is explained in the long form of periodic table in the modern periodic table. This is called as long form of periodic table in the modern periodic table, we can say that. So in this way we can have the knowledge of the position of the element in the periodic table, where it is being placed. Alright, from the electronic configuration we can find it out, where the element is placed, in which period it is placed, in which group it is placed, what should be the properties, everything we can know about it, the nature of the element, the nature of its compound. Alright, so all these are being possible from the long form of periodic table. These are the merits, or these are the uses, or these are the advantages of the modern periodic table, so to say. I hope you understood about it. Thank you.